So now that we have covered translations, where we're moving functions up and down, reflections, where we're finding the mirror image of a function, and stretches, where we're actually changing the distance between points of a function, we're ready to combine all three types of transformations all at once. Here we go. Ensuring that a function is written in this form. Now we've seen each of these letters on their own independently. Our new function is going to be y equals a f. That's telling us where our function is. Our function is going to be at k x minus d, close the bracket here, not there, plus c at the end. Will allow you to specify the transformations being applied to a base function. Stretches, compresses, and reflections have to be done first. These first. Doesn't matter which order, but all three of these have to get done before we can do any movements second. Never do this first and then these second. Stretchy first, move after. Let's do some review. Again, the bracket should be here, not there. The parameters a, k, d, and c in this function correspond to the following transformations. A is a vertical stretch. A is vertical. C is a vertical translation. So A and C change how it looks up and down. D and K are horizontal. K is a stretch, D is a move. These affect the x. Horizontal, side to side. So we're ready for our first example. Describe the combination of transformations that must be applied to base function f of x to obtain the transformed function. Then write the corresponding equation and sketch the graph. I'm going to work on this guy over here. So, first thing, we need to know what transformations do I expect to see? Well, we're going to compare. Our g of x is looking like -2. Here's our function, 3x plus 15 plus 4. Alright, that's nice. What should it look like? It should look like y equals a, f, k, x minus d plus c. So in this, fairly clearly, I can see what my a is. A is -2. I can see what my c is. C is +4. But if I look in here, somebody's played a trick on me. My bracket here does not look like my bracket here. You have to watch out. If you have two different terms, you can have two terms in this bracket, that's okay. But x has to be by itself. There cannot be a number in front of x. That means we're going to have to factor out this 3. This is going to become 3x plus 5. This bracket has become this bracket. We'll copy everything else as is. And now we can see that our a is -2. This tells me we have a vertical stretch of 2. We can see our c equals +4. This is a vertical move. It's positive up 4. So a and c, both vertical. Very simple. Whatever number is here, that's a stretch of whatever number that is. Sorry, it's a -2. My mistake. That's indicative of a reflection as well. -a, therefore reflection in x-axis. It's when we look at the horizontal stuff that things get a little weird. For our horizontal stuff, we can see that our k is 3. K equals 3. That's a horizontal stretch by a factor of 3. Now look at this. We have to watch carefully. We see that d should be a negative number, but I see a positive number here. So what value must D have been to give an overall positive value here? Well, D could be 5, but if D was 5, then it would be x minus 5, not x plus 5, because of this negative. So that must mean D must be negative 5. This is a horizontal shift. We're actually going to move it to the left 5. So if we look at the instructions, we have identified the transformations that have to be applied to the base function. Then we have to write the corresponding equation. Well, here's our g of x. What was f of x? F of x in this case was square root x. So this means instead of having the f around this bracket, we're going to have the square root around this bracket. Our g of x is going to be negative 2. Instead of f, we're going to have square root 3 x plus 5, and then plus 4 on the outside. So we still maintain a, k, d, and c. Now that we have identified all of our transformations, we're ready to apply them. So we have to remember, stretches and compressions, reflections, all that good stuff happens before translations, before we move. So let's take a look. Our original function, our f of x, is our favorite old trusty square root x. So square root x, 0, 1, 4, and 9 are my favorite numbers to use for square root x. 0, 1, 2, and 3. 16 and 4. May as well go whole hog, use everything. We know that if we have a vertical stretch, and we do, we have to apply this a to our f of x, to our dependent variable. So this is going to tell me that we have to take our f of x, and we're going to multiply it by negative 2. We also have something affecting our x value. That's our k. Our k is 3. This means we take our x's and we multiply by 1 over 3. It's always the reciprocal. Oh, I'm sorry. It's the reciprocal for the x terms. Negative 2 comes from our a term. 3 is what's giving us 1/3 here. So I'm going to take 0 and multiply by 1/3. 0 times 1 over 3 is still 0. 1 times 1 over 3, I'm going to write it as a decimal so it's easier to graph, 0.3. 4 times 1 over 3, 1.3. 9 times 1 over 3, 16 times 1 over 3, about 5. We're going to take our f of x, these numbers, and multiply them by negative 2. 0 still, negative 2, negative 4, negative 6, negative 8. These are what we're going to plot. But we can take this one step further. We can take these numbers and we can apply our translations as well. Translation is just a move up or a move down, a move to the left or move to the right. We know that we're going to take each of these x coordinates and horizontally translate them. We're going to shift them 5 left. So that means that it's not going to be 5. This is not going to be a 0. We're going to do 0. We can write this as x times 1/3 because we've already done that. Then we're going to take that answer and minus 5. So we get 0, take away 5 is negative 5. 0.3 take away 5 is negative 4.6. 1.3 take away 5 is negative 3.6. 3 take away 5 is negative 2. 5.3 take away 5 is 0.3. For our horizontal change, we've got a plus 4. So that means we take what we had up here which was f of x times negative 2. Now we're going to add 4. 0 plus 4 is 0. Negative 2 plus 4, positive 2. Negative 4 plus 4 is 0. My bad. 0 plus 4 is not 0, but it's 4. Negative 6 plus 4, negative 2. Negative 8 plus 4, negative 8. I'm sorry, I can't seem to add today. Let me make sure I go through that again and check. I take this number, my previous f of x multiplied by negative 2. I'm going to add 4. 0 plus 4 is 4. Negative 2 plus 4 gives me positive 2. Negative 4 plus 4, 0. Negative 6 plus 4, negative 2. Negative 8 plus 4, negative 4. These end up being the points of my final function, my transformed function. So if I take them up here, I see that my first point is negative 5, 4. Negative 5, positive 4. My next point is 0.46, 2. So only a little bit over, but we're already dropped to 2. Negative 3.6, 1, 2, 3.6. We're at 0. Negative 2, negative 2. Positive 0.3, negative 4. There's my g of x. For our last example, we're going to take this function here. It's not a function that I know. It's its own unique function, not any base function. But here it is graphed, and I can transform it into any of these 4 new functions. Given the graph below, f of x, so here's our f of x. Sketch the graph of g of x, after each transformation. And I'm going to go with this last one over here. Alright, so my g of x, let's see if this makes sense. So g of x is 5, 0.5 times x plus 1. So we're falling into a problem here. This does not match our mapping notation that we like. If you see, we have an x with a plus sign in this bracket, so we have 2 terms in the bracket, but the x is not in front. There needs to be a bracket in front of x or no plus sign if there's going to be a number. So this means we have to factor out the 0.5. This means dividing this term by 0.5 and this term by 0.5. F5 stays out front. Let's put a big bracket. So I'm going to bring the 0.5 out. X is now x. 1 divided by 0.5 is actually 2. So what I've done is divided both of these terms by 0.5 to factor it out of this bracket so that it can match the mapping notation that we did on the previous slide. Now I know my a equals 5, my k equals 0.5, which if I remember my fractions is a half. And here I have d is negative 2. Remember, d's always go in the opposite direction. They should. If it's positive 2, that's telling me it's a shift to the left 2. This is a horizontal compression by 0.5, and this is a vertical stretch by 0.2. By 5, excuse me. How am I going to do this when I don't have a base function? Well, they were kind enough to give me points, A, B, C, D, E, F, and G. So let's write out our own points for base functions. Here's x, and here's f of x. What's my first point? We'll go with A. We've got 5, 6. Here's 8. Negative 8, 2 is my first point. My second point is 5, 6. Negative 6, 4 is my second. Negative 2, 4. And it goes to 0, 2. Here we have 2, 0. 3, 1. 6, 1. Just gone off each of these points, read them off. What's this point? What's that point? According to the axes here. So that's my new base function. How am I going to map this for my new g of x? Well, I'm going to take the x's and I'm going to multiply by 2. Take 1/2, reciprocal, 1 over 2. I'm going to take my f of x's and I'm going to multiply them by 5 because of the a term here. As long as I'm at it, I can subtract 2. Let's do it in the next step. So we take our x and we multiply it by 2. We get negative 16. Negative 6 times 2 is negative 12. Negative 2 times 2, we got negative 4. There's our 0, 4, 6, and 12. We're going to take each of these numbers and multiply them by 5. 2 by 5 is 10. Here we've got 20. 4 times 5 is 20. 2 times 5 is 10. 0 times 5 is still 0. 1 times 5 is 5. This function likes it so much it uses it twice. Okay, so now I've applied my a's and my k's. Now I need a shift. I have a vertical shift. A horizontal shift, but no vertical shift. This means that my last number is going to stay the same. This one is going to be moved left 2. That means I'm going to take each of these numbers, x times 2, and I'm going to subtract 2 from each of these. Negative 18, negative 14, negative 6, negative 2, 2, 4, and 10. So now, this is what I'm going to plot. I've applied my 5 by multiplying all my y values by 5. I've applied my 0.5 by multiplying all my x values by 2. And I've applied my plus 2 by subtracting 2 from each of my final x values. I've applied the stretches before I've applied the translations. So my new functions are going to be, so these are the guys that I'm going to plot. Negative 18, 10. Negative 18, 10. Next one is negative 14, 20. Negative 14, 20. Negative 6, 20. Negative 6, 20. All the way up there. Negative 2, 10. Negative 2, 10. Negative 4, 5. Positive 4, 5. And 10. Oops, I must have missed something. There it is. 2 and 0. X equals 2. Y is 10. Positive 2 is 0. And 10 and 5. X is 10, Y is 5. So if you look, excuse me while I move the page, it's got the same kind of characteristic shape as our original one does, but a very different scale.